All right, so 4.1 homework, how to do this by graphing. All right, so question 1. So you're probably fine with this problem. Plugging those
Yeah,
numbers in, see if it's,
that's the only one I got right.
oh no, okay. All right, y equals negative 3x plus 6. All right, so choose a tool. So we'll graph y equals negative 3x plus 6. So we have a y-intercept of 6. And then we know the line has a slope of negative 3, so it goes over 1 and then down 3. So there's that line. The other line has a y. Okay, go ahead.
Sorry, is it supposed to show on the screen?
What do you? Uh, what do you? Oh, yep, yep. Thank you. You're still seeing.
Sorry.
No, no, you're still seeing my PDF annotator. Okay. So I go back to here. New share, and you want to see. Okay, can you see it now?
Yes, thank
Okay,
you.
there you go. Okay, so I'll start that over again. Enlarge the graph, and we want to graph negative 3x plus 6. So I use the line tool. I go to the y-intercept of 6, and the slope is negative 3, so rise negative 3 and run 1. So we went right 1 and down 3, and then we put that point there. And so that's the graph of the first line. Is that okay?
Yeah. Okay, yeah, I see it.
Okay. The next one has a y-intercept of negative 2. So we go to negative 2, but now this one has a slope of negative 1/3. So if I drop 1 and then run 1, 2, 3, that's going to be the point of intersection there. It looks like it's at 3, negative 3. Yes. Okay. So we check that answer to make sure those lines are correct. And then the solution is,
3, negative 3.
yeah, so the solutions, we have to write as an ordered pair. So parentheses 3, comma, negative 3. And then we check that.
How do we tell that it's 3, negative 3 again?
Because if I enlarge that graph, we see that it goes over 3 and then down negative 3. It's that point of intersection.
Oh, okay.
Do another one like this. So we would have to, on this one, we'd have to do a little bit of work on our paper first. And so let's see, how do I want to show this to you? Okay, so here's our, you're seeing the PDF. You're seeing this PDF now, right, where I'm writing?
Yes, I am.
Okay. So my first line is negative 3x equals 3 minus y. And so if I add y to both sides, that's y minus 3x is 3, or y equals 3x plus 3. And then this one, all I have to do is divide both sides by 2. Well, that tells you that that line's also y equals 3x plus 3. That tells us pretty much everything right then and there. if these two lines turned out to be the same line, both of them are y equals 3x plus 3. When I graph the first one, it's y equals 3x plus 3. So I go to y equals 3, and then I go over 1 and up 1, 2, 3. That's the first line. And the second line is right on top of that one. So I put another point, and then the line right on top of that. And then those are the same exact line. So it tells me that's fine. And so then when they're the same exact line, there are infinitely many solutions because there's all of the points on the line where they intersect. So when you take your system of equations and write them both in slope-intercept form, that usually tells you a lot about your system. If it's the same slope and the same y-intercept, then we write infinitely many solutions. If it turns out to be the same slope and then different y-intercepts, that would mean that your two lines don't intersect, they're parallel. So the next problem is probably something like that. But if it turns out in slope-intercept form and they have different slopes, then you're guaranteed to have that point of intersection. This is the first time I've ever done this where I show people how to do my math lab going back and forth. This is cool.
Oh, sorry.
No. I'm happy to do it.
Thank you.
I'm happy to do anything you guys want me to do online, especially if you're the only one who shows up. You get to ask me whatever. Okay, so the first one's y equal negative x plus 5. That one's in slope-intercept form. Its slope is -1 and y-intercept 5. So we put a point at 5, and then we just go over 1 up 1. And that's that line. But this one's not too bad, because if we divide by 2, that's a slope of 1/2. And then 10 divided by 2 is 5. So these have... Oh, I was supposed to graph this one. These have different slopes, so they intersect. So it's y-intercept of 5, and it's a slope of rise 1 and run 2. Okay, so these do have a point of intersection. Which one did I graph incorrectly here?
I think it's the first one.
Yeah, the first one's wrong because it was slope of -1.
Okay, cool, because I was confused.
-1, there we go.
I've noticed a lot of graphing. Is the majority of the exam graphing?
The majority of the exam graphing. No, I wouldn't say the majority because a lot of it's chapter 2. I mean, some of it's chapter 2. And chapter 3 has a lot of graphing on it, but some of it is finding equations of lines and finding intercepts.
Okay.
But there is a lot of graphing on there. Oh, so I ended up getting that wrong.
No, yeah, it's really hard to graph these online.
Let's all parts showing. Let's do another one of those. So y equal negative x plus 5. That's a y-intercept of 5. And then a slope of -1. The next one is a y-intercept of 5 as well, and its slope is 2/3. So we rise 2 and run 1, 2, 3. Okay, that's better. And then that solution is 0, 5 like the other one. Okay, so this is the one that I was looking for right here. Okay, so do you see on these two lines? Have you do you know how to find the intercepts of these lines?
Um, I'm gonna go with no.
Okay, so see how it's okay. Let me copy paste that then, and we'll look at this one. Okay, can you see this now?
Yeah.
All right. So if I have 3x minus y equals 6, then putting it in slope intercept form, we subtract 3x from both sides,
Oh.
and then we divide by -1. And that gives me y equals 3x minus 6. Is that clear?
Yeah.
Okay. Now from this, the slope is 3 and the y-intercept is 0, -6. So we're going to do something like going down to -6 and then rising 3 and running 1. And we'll do that on the graph paper over there. But what I was asking you about is intercepts. One of the questions on the review that you'll see asks you just to find the intercepts of these lines. And the y-intercept is found by setting x equal to 0. And so if you do that, that's just 3 times 0 minus y is 6. That's just 0, which is -y, or the opposite of y is 6. And that says that y is -6. And that's the one we just found by writing in slope intercept form. The x-intercept is the opposite. So the y-intercept is where x equals 0. And the x-intercept is where y equals 0. That's going to be this point right here. And when you set y equal to 0, you have, again, working with this equation right here, we have 3x minus y, or 3x minus 0 equals 6. And so that crosses out and you just have 3x equals 6, or x equals 2. So that intercept is 2, 0. So sometimes when I graph these, I'll just look at that first line and say, well, that 3 goes into 6 2 times. So my first point is 2, 0. And my second point, since -y equals 6, so that's 0, -6, I'll just graph those using intercepts. Or if you don't like that, then you just go back to that slope intercept form we found, y equals 3x minus 6. And we go down to -6, and then we rise 1, 2, 3, and run 1. And so that's our first line. Are you seeing what I'm writing now?
Yeah.
Okay, good. The other line, this is interesting now because when I subtract 6x from both sides here, I have -2y is -6x plus 6. And then we have to divide by -2 to get y by itself. And this time we end up with y equals 3x minus 3. So compare these two lines, and they have the same slope, but different y-intercepts. And so anytime two lines have the same slope and different y-intercepts, this one's going to go through 0, negative 3, but it's going to have the same exact slant to it. Are there any solutions to something like this then? Is there a point of intersection?
No.
No. So when you see parallel lines like this gives you no solution. And so I was able to see this right when I started, and I'll show you why in just one moment, because now we put the y-intercept at negative 3, and we rise 3 and run 1. What are you doing? And there's our two lines. And because they're parallel, we say there is no solution. But I was able to see that because 2 times 3 is 6, and 2 times negative 1 is negative 2y. When you can multiply by the same number and get the second equation, it's the same slope, but that 2 times 6 didn't give me 6. It should have been 12 to be the same line. That's one way you can visualize those or see if you're going to have no solution or not. But you don't really have to see that, because you can always just write it in slope-intercept form, and then you'll see if you have those cases. So does that help you? Do you want me to continue on with more problems, or?
No, that helps me. The one thing that like I really got confused on is if it was like a previous homework assignment online, it would say, oh, graph y equals 3. So you literally have to do like a straight line of 3, but it would never let you graph just like one point.
Oh, yeah. Because the line y equals 3 has a lot of points on it, so it wants you to put more points where y equals 3.
Oh,
So that's something that would be worth going over with you.
I can't remember what homework it was.
Well, no. Well, I'll just go over it in terms of the review. So look at this. Whenever you graph, and if you watch the videos, I talk about this mnemonic device to memorize these things. When you graph an equation that says y equals negative 2, that means that no matter what x value is, y needs to be negative 2. So 3, negative 2, 5, negative 2, 7, negative 2, 9, negative 2. So all of these points on here, so you would put on the MyMathLab, you'd put a point there where y equals negative 2, and then maybe a point there where y equals negative 2. And then it would continue. It would go ahead and make your line for you.
oh,
And so in the video, I talk about this mnemonic device that I call OI. Because if it's an equation that has only a y in it, then it turns out to be a horizontal line. And so the y stands for the equation only has a y in it. And what do you think this O stands for? Any idea?
no.
It's really a 0.
Oh,
Because the horizontal lines have zero slope. Zero slope because if you talk about rise and run, in going from any point to another point, you're not rising at all, you're just running some number like 4. And the rise is 0, and when you have 0 in the top, 0 divided by 4 is 0. So we say that horizontal lines have equations that are always a y equals a number, and their slope is 0. And so what's the opposite of a horizontal line?
Parallel?
No, if you have the opposite of a horizontal line is going to be a vertical line.
Oh, yeah.
So if the x's have to always be 3 this time, then my y values can be anything. So if the x's are always 3, 3, 5, 3, -4, 3, 7, 3, -2, then when I connect those dots, I get that vertical line. And so then I talk about this mnemonic device, VUX, VUX, because if it's always an x equals a number, then these are vertical lines. And do you know what the U stands for there? Did you see slopes of vertical lines yet?
Probably.
Yeah. So in moving from any point to another point on the line, this time it's all rise and no run. And when you do rise over run, say you rose 5, your run is 0, and you can't divide by 0. Division by 0 is undefined. And so we say that the slope of a vertical line is undefined. And so that's how you memorize those things. If it's only y equals, it's horizontal. If it's only x equals, then it's vertical. And that's how you memorize the slopes of vertical and horizontal lines, the VUX and the OI. So then also what happens is y equal -2x. If you have a y and an x in the equation, then it can't be a horizontal or vertical line. This one says y equals mx plus b. The slope is -2 and the b is 0. So you go to b equals 0, and then the slope is -2 over 1. So you rise -2 and run 1. Rise 2 and run -1. All right. Anything else you want to go over here? We could continue on if you want.
I think I'm okay with 4.1 now.
Yes.
And I didn't have any problems with 4.2.
Oh, good.
Oh, what? There was a homework problem on 4.2 where it was like, it didn't have like a number in front of the x or the y. It was literally like y equals this is this, y equals this is this for both equations.
It didn't have a number in front of the y.
Yeah, like it was already preset to like y equals this, y equals this. Like there was nothing for me to change.
Yeah. Okay. So that's 4.2.
Yeah.
All right, those are yeah, those are pretty. Those are supposed to be easy that it confused you, and that's what happens a lot of times. Okay. So I know you're used to seeing something like 3x minus y equals 4, and then maybe like y equals 3x plus 2,
Yeah.
and then you take that and you substitute it in for y and get 3x minus 3x plus 2 equals 4. Okay, so what you're telling me is if we had, say, like y equals 3x minus 4 and y equals 2x plus 6, something like that?
Yeah.
Good. So just think about taking this y value, which is 2x plus 6, and substituting where you see y there. So you would just take 2x plus 6 and set it equal to 3x minus 4.
Oh.
Yeah, exactly. And so then you just would have to subtract 2x from both sides. And that gives you x on the right side, and then add 4 to both sides. And get 10.
And then how would I find y?
So you either plug it back into y equals 3x minus 4,
Oh.
or you plug it back into y equals 2x plus 6. If I plug it in there, that's 30 minus 4, which is 26. If I plug it back in there, that's 20 plus 6, which is 26. So we would say it's 1026.
Thank you.
Oh, you're welcome. Anything else?
For Thursday,
Yes.
are you going over the exam, like the exam review, or are you going over new homework?
Well, no one's really coming to these anymore. The last one, no one even showed up. So I just am online, and whoever shows up, I ask them what they want to do.
Okay. Um, yeah, I struggle coming to Thursdays just because like it's my busier day and like last week, yeah, I was just like super busy, but I wasn't even realizing that you were doing two a week. I thought you only did one, so yeah.
Yeah,
Um,
I mean, you're not required to come to these. They're really just for you if you want the extra help. So don't feel bad if you can't make it.
um, I feel like I'm good with everything, but I have a feeling that when we leave the meeting, I'll be like, oh, here's six more questions that I don't know how to do.
Yeah.
Um, I think I'm okay.
All right.
Thank you for helping me.
Yeah, you're welcome. So I would encourage you to try to do that review in the next couple of days. And then if you have any questions on it, show up on Thursday if you can. And then we can go over the review problems in this webinar. I would imagine other people are going to show up. That's usually get a couple more people showing up when there's a test coming up.
Okay, sounds good. Actually, I do have one question
Yeah, go
on
ahead.
your announcement or your like message about the exam. You
Yeah.
said that it will be, I think you said 2 hours and ends a certain amount of minutes. Is that how long we have to stay, or that's like the estimated time to finish?
If you're a fast test taker, people could finish this test in maybe an hour and 10 minutes. And if you're somebody who takes your time, it's going to take you 2 hours and 25 minutes.
So is that you saying that like we cannot go over 2 hours and 25 minutes?
Um,
Not that I would.
I do normally cut it off at about 2 hours and 25 minutes, but I really don't have a problem allowing a little more time. I don't want to do an unlimited time, but I just I pretty much say that because a lot of people show up, an hour and 20, 30, 40 minutes before TLC closes, and they say to them, well, you've just basically eliminated yourself some time. So
Yeah.
I tell that so people show up early and give themselves enough time.
Okay, and are you there to give us the test, or do we go
You
to
show up,
somebody?
no, there's a testing center in the TLC lab. You walk in and then just kind of veer left and go all the way back, or ask where the testing desk is, testing
Okay.
center, and they're the ones who are going to give you the test.
Okay, sounds good.
All right.
Well, thank you.
Okay, you're welcome. I'll talk to you later.